Hello everyone, welcome back to my channel. In today's video, we're going to learn how to conduct a logistic regression analysis in RStudio. As you may know, in general, there are three types of logistic regression algorithms: binary, ordinal, and multinomial logistic regressions. We call it binary when the response variable is binary. Ordinal is used when the response variable has three or more possible outcomes. And finally, multinomial is when the response variable has three or more possible outcomes, but with this difference that there is no specific orders here, quite opposite the ordinal one. So here our example is a binary type. We have a data set about cases of coronary heart disease, or in a short form, CHD. We have our observations as the patients and 10 conditions or variables related to them. We want to predict whether the patient has CHD, coronary heart disease, or not. So the outcome or response variable is the diagnosis of CHD, which is a binary one with 0 or 1 outcomes. So variables are SBP, systolic blood pressure, yearly tobacco use, LDL, low density lipoprotein or bad cholesterol level, adiposity, family history, type A personality score, obesity, which is measured by body mass index or BMI, alcohol use, age, and our target variable CHD. We want to figure out the relationship between these variables and the response variable. So go ahead and open our script file. We have 3 steps to do here. First, exploratory data analysis. Second, model fit, and finally, model prediction. As usual, first we need to install or call libraries and then load the data set. Then use dim and head functions to get a dimension of the data set and get a sense of what we are dealing with. And then the first 6 rows of the variables. Then we will convert our target variable or CHD into a factor, because when we want to model our data set, we need the CHD or target variable to be a factor. So to do that, use as.factor function. Then again, to get a sense of how family history is related to having a CHD or coronary heart disease, we plot it, because this is the only categorical variable that we have in this data set. So we use ggplot function, run it, and you see the result in the plot window. For those that have a record of this disease in their family, the chance of getting CHD is almost 50%. Which is noticeable, while for those that did not have the CHD record in their family, the chance of having it is quite lower. So it is not shocking, we were expecting that. Now let's move on to the next step, where we are going to split our data set. We do that because we want to make a better prediction, and we see if our model is also working on unseen data. So we split the data into 2 sets: a training set for fitting the model and a test set for model evaluation, to make sure that the model trained works on unseen data as well. So use initial underscore split function, and also set the proportion of the data to 0.8, meaning that we will be using 80% of the data set allocated to training set. Then we fit the model. We set mixture as ~1, which indicates the last model, and set engines as glmnet. Engine is the software that is used for calculations, and here the calculation means classical logistic regression. Then we call the fit method to train the model on the training data. Excuse me. CHD is the target variable, or Y, and this period or dot means that we are concluding all variables in our model. Then we'll get a summary of the model by tidy function. So run it, And here is the result in the console window. Estimate column represents coefficients of a predictor. And you see these red ones show that they are negative and have an inverse relationship with the target variable. Now we move on to the next step, which is making predictions on the testing dataset. So use predict function. We have two types of predictions. One based on the class that returns the most likely target value for each observation, 0 or 1, meaning that they have the disease or they will not get the disease. And the other one is based on the probability that returns the probability of each target value for each observation. You see them here in these tables. So now we're going to evaluate the model by accuracy function. You see it's 72%, so it's an acceptable amount. I just want to mention something before ending this video, and it is that we can use more evaluation matrices as well, like confusion matrix. But I think what we have done so far is pretty good and quite enough, because we just got a sense of our model and we saw that it works. So that was it. That was the process of conducting a logistic regression analysis in RStudio. I hope you liked it and found it helpful. And if you did, please subscribe to my channel and give this video a thumbs up. And I'll see you in the next one. Bye.